Hello there, and welcome to the Sleep with Science channel. Close your eyes now, if you feel ready. Let your body sink a little deeper into whatever is holding you, your bed, your pillow, the soft weight of your blanket pulled just to the edge of your chin. There is nowhere you need to be tonight. Nothing you need to solve. Nothing left undone that cannot wait until morning. Tonight, we are going somewhere together. Somewhere so vast, so beautifully incomprehensible, that the ordinary worries of your day will simply dissolve, like breath on a cold winter window, before we have even truly begun. Take one slow breath in through your nose. Hold it gently, and let it go. Feel your shoulders drop. Feel the muscles behind your eyes soften. Feel the quiet settle around you like the first snowfall of winter, muffling everything, smoothing every sharp edge into something gentle, something still. I want you to imagine the night sky above you, not the sky you might see from a city, washed pale and hollow by the orange glow of streetlights, but a true sky. A real sky. The kind of sky our ancestors watched in wonder from open plains and mountain ridges, before the world filled itself with electric light and noise. A sky so dense with stars that the darkness between them almost seems like the exception rather than the rule. A sky that breathes. A sky that hums with a silence so deep it has its own texture, its own weight, its own velvet presence pressing softly down against the earth. You are lying beneath that sky right now. The ground beneath you is warm from the day's sun, still holding the last traces of that golden heat. The air around you is cool and clean. And above you, stretching in every direction, curving away at the edges of the horizon, is the universe. Not a picture of it. Not a diagram from a textbook. The actual, living, breathing, ancient, impossible universe itself. There are, in the observable universe alone, somewhere in the neighborhood of 2 trillion galaxies. Not 2 trillion stars. 2 trillion entire galaxies, each one containing hundreds of billions of stars of their own. The number is so large that if you tried to count a single galaxy's stars at the rate of 1 per second, it would take you over 3,000 years just to reach the end of one. And then you would have 2 trillion more galaxies waiting patiently in the dark. Let that settle over you like a warm tide. We are small. Wonderfully, peacefully, profoundly small. This tiny blue world we live on, with all of its beauty and noise and history and heartbreak, all of its cities and oceans and mountain ranges and every human being who has ever drawn breath, fits inside this universe the way a single grain of sand fits inside all the beaches of all the world's coastlines combined. Perhaps smaller than that. Perhaps smaller than that by a measure our minds were never designed to fully hold. And yet, and here is where something extraordinary begins to quietly stir, in all of that incomprehensible enormity, across all of those trillions upon trillions of worlds circling trillions upon trillions of suns, across the 4.5 billion years that our own planet has been spinning through space, across the 100,000 years that beings who look like us have stood beneath this sky and looked upward with wondering eyes. In all of that time and space and possibility, we have found no one. Not a signal. Not a footprint. Not the faintest whisper of a transmission cutting through the static of the cosmos. No ancient ruins on the moon. No megastructures orbiting distant stars, though we have looked carefully. No pattern hidden inside the background radiation of the universe, waiting for someone patient enough to notice. The sky, for all its overwhelming abundance, for all the staggering mathematics that suggest life should be not just possible but almost inevitable in a universe this large, the sky has answered us with nothing but its own magnificent, unbroken silence. Scientists call this the Fermi Paradox. It takes its name from the physicist Enrico Fermi, who in the summer of 1950, over lunch with a group of colleagues, paused between bites and asked what seemed in that moment like a casually simple question. If the universe is this old and this vast, and the physics that built life on Earth seem to operate everywhere we look, then where is everybody? It is a question that sounds almost playful at first, almost light. The kind of thing you might ask with a half-smile, expecting someone across the table to laugh and offer an easy answer. But no easy answer came then. And in the 75 years since that quiet lunchtime question drifted up into the air and never quite came back down, no easy answer has come yet. What has come instead are theories. Dozens of them. Some of them beautiful. Some of them strange. And some of them, the ones whispered about most carefully in the corners of scientific conferences, the ones that certain researchers write about and then pause and look out the window before continuing, some of them are genuinely, quietly, terrifying. Not in the way that horror movies are terrifying, with their sudden sounds and their darkness manufactured to startle. This is a different kind of fear entirely. The kind that arrives slowly, the way cold arrives in a room when a window has been left open somewhere you cannot find. A chill that builds so gradually you almost do not notice it until you realize your breath has gone shallow and something deep inside you, something older than language and older than thought, has begun to pay very close attention. But we are not there yet. Not quite. Tonight, we are going to walk toward that question together, you and I, slowly and gently and without rushing. We are going to let it unfold the way the universe itself unfolds. Not all at once, not in a blinding flash of revelation, but gradually, layer by layer, the way the sky reveals itself after sunset. First one star appearing where there was nothing. Then another. Then 10. Then 1,000. Until suddenly you are standing beneath something so enormous and so full that you cannot quite remember what the empty sky looked like before. So let us begin at the beginning. And the beginning, in this case, is a number. The number is called the Drake equation, and it was written down for the first time in the autumn of 1961, inside a quiet conference room at the National Radio Astronomy Observatory in Green Bank, West Virginia. Outside, the mountains of West Virginia were turning their slow seasonal gold and amber. Inside, a young astronomer named Frank Drake stood at a chalkboard and wrote out something that looked, at first glance, like a fairly straightforward piece of mathematics. A formula. A way of estimating, given everything we know about stars and planets and the conditions that seem to produce life, how many intelligent civilizations might exist in our galaxy right now, at this very moment, capable of communicating with us if only they tried, or if only we listened carefully enough. Let your breath slow down just a little more as we hold this thought together. The equation asks a series of questions, one nestled inside the next like a set of doors opening onto further doors inside a house that goes on longer than it should. How many new stars form in our galaxy each year? Of those stars, how many have planets orbiting them? Of those planets, how many exist in what astronomers call the habitable zone, that narrow, tender band of distance from a star where temperatures allow liquid water to exist, where the conditions for life as we understand it become not just possible but genuinely plausible? Of those habitable planets, how many actually develop life? Of those that develop life, how many go on to produce intelligent life? Of those, how many develop technology, communication, the ability to reach out across the dark? And of those, the final door, the one that opens onto silence, how long do they survive? Drake gathered his colleagues around that chalkboard and they worked through the numbers together. And the answer that emerged from those calculations was not a small one. Even using conservative estimates, even when they were careful, even when they were skeptical, even when they deliberately chose the lower end of every range, the mathematics kept suggesting that our galaxy alone should be home to somewhere between 1,000 hundreds of millions of civilizations capable of reaching across space and making themselves known. Let that breathe for a moment. 1,000 at the very lowest. Possibly millions. In a galaxy of 400 billion stars. Civilizations with languages and histories and technologies, perhaps far older than ours, perhaps looking up at their own skies and asking the same quiet questions we ask when we look up at ours. The numbers, the pure impartial mathematics of stars and time and probability, suggest that the universe should be extraordinarily populated, should be humming, should be alive in ways and in scales that dwarf anything our small imaginations have managed to picture. And yet, you already know what comes after that, and yet, you felt it in the silence that has always been there, just underneath the surface of the question, since the first time someone told you that space was vast and life might exist elsewhere. And isn't that something to wonder about? The silence is the thing. The silence is what changes everything. Because silence, in a universe this old and this large, is not neutral. Silence, against that backdrop of 2 trillion galaxies and 400 billion stars in our galaxy alone, and billions of years of time in which life could have arisen and spread and traveled and built and reached outward, silence, in that context, does not feel like an absence. It feels like an answer. And the question we have not yet dared to ask directly, the one that sits at the very center of everything we will explore together tonight, is this. What kind of answer could silence possibly be, in a universe so full of everything else? The stars above you right now hold no expression. They burn with the same indifferent, ancient light they have always burned with, the same light that fell across the faces of the very first human beings who tilted their heads back and wondered. Some of that light left its source before our planet even existed. Some of it has traveled so far, through such absolute and perfect emptiness, that the star which sent it has already died and collapsed and cooled into something dark and cold and forgotten, somewhere out in the dark between galaxies, with nothing left to mark the place where it once burned so brilliantly that it outshone everything around it for 100 million miles in every direction. We are looking at ghosts when we look at stars. Beautiful, ancient, silent ghosts. Light that carries no message except the simple, staggering fact of its own existence. Light that says only, something was here. Something burned here once, in the dark. And then, because the universe does not explain itself, because it offers no footnotes and no apologies, the light simply continues on its way without waiting to see if anyone noticed. Let that image settle over you softly, like something placed in your hands with great care. Something was here. That phrase is the heartbeat underneath everything we are slowly unwrapping together tonight. Because the question of whether we are alone is not really a question about space, not at its deepest level. It is a question about existence itself. About what it means for something to arise from nothing, for matter to organize itself, over billions of years of patient chance and chemical conversation, into something that opens its eyes, looks outward and wonders. The fact that it happened here, on this small warm world, is either the most ordinary thing in the universe or the most extraordinary. And the silence, that vast, unbroken, cathedral silence that greets every instrument we have ever pointed at the sky, has not yet told us which one it is. There is a way that astronomers sometimes describe our search for extraterrestrial intelligence, and it is an image I want to place very gently in the space behind your closed eyes as your body continues to grow heavier and more still. Imagine the ocean. Not a sea, but a true ocean, the Pacific, perhaps, in its full and almost incomprehensible breadth. More than 60 million square miles of dark salt water, stretching from horizon to horizon in every direction, deeper in places than Mount Everest is tall. Now imagine that someone has given you a single glass. Just one ordinary drinking glass. And they have told you to search the ocean for signs of life by filling that glass once, examining what you find inside it, and drawing your conclusions. That is, more or less, how much of the universe we have meaningfully searched for signals of intelligent life so far. One glass from the Pacific Ocean. And we have looked into that glass and found nothing, and some part of us has quietly begun to feel the weight of what that might mean, while another part of us, the wiser and perhaps more honest part, knows that we have barely even begun to look, that the ocean is still out there, vast and dark and full of depths we have not touched, full of frequencies we have not listened to, full of distances our signals have not yet crossed and may not cross for thousands of years to come. The absence of evidence, as the saying goes, is not the same as evidence of absence. And yet, and here that quiet word surfaces again, the way something cold surfaces from deep water, and yet the silence does something to us. It does something particular and strange and difficult to name. It opens a space inside the mind, a kind of interior vastness. And into that vastness, the imagination begins, very slowly, to pour its most careful and its most unsettling thoughts. Because here is the thing about the Fermi Paradox that separates it from most scientific puzzles. Most puzzles feel, at their core, like invitations, like doors that are simply waiting for the right key. We do not know yet how consciousness arises from matter, but the question feels navigable. We do not know yet what lies at the center of a black hole, but the question feels like it belongs to the same continuum of knowing and discovering that science has always traveled. These are questions that feel, in some essential way, friendly, patient, willing to wait for us. The Fermi Paradox does not feel like that. The Fermi Paradox feels like a question that looks back at you. It has a quality that is almost impossible to describe precisely, but that nearly everyone who has sat with it long enough eventually recognizes. A quality of weight, of implication, as though the question itself knows something it is not yet ready to say out loud, and is watching carefully to see if you are the kind of person who can bear to hear it. Scientists who have devoted years or decades to thinking seriously about this question often describe a moment, sometimes early in their research, sometimes much later, after years of careful and methodical work, when they suddenly felt the ground shift slightly beneath them. When the question stopped being abstract and became, in some intimate and irreversible way, personal. Because there is no answer to the Fermi Paradox that leaves everything exactly as it was before you understood it. Every solution that has ever been seriously proposed, every theory that has been examined and tested and argued over in journals and conference rooms and late-night conversations between people who study these things for a living, every single one of them, without exception, changes something fundamental about how we understand our place in the cosmos. Some of them change it in ways that feel, at first, almost comforting, almost like a relief, a simple explanation, a gentle reason. But others, and these are the ones that tend to arrive last, after the simpler answers have been considered and quietly set aside, others reach into the center of what we think we know about life and intelligence and the future, and they rearrange it. Not violently, not with the crash and splintering of something broken, but with the slow, inexorable pressure of deep water finding its way through stone, patient, inevitable, and permanent in a way that nothing can quite undo once it has happened. So tonight, as your body rests and your breath continues its slow and easy rhythm, we are going to move through these answers one by one. We are going to hold each one up to the light, the way you might hold a piece of sea glass found on a quiet beach, turning it slowly, feeling its weight, noticing the way the light passes through it differently depending on the angle, depending on how willing you are to really look. Some of what we find will be beautiful. Some of it will be strange. And some of it, the pieces we save for last, will carry that particular quality of cold that has nothing to do with temperature and everything to do with understanding something you cannot quite ununderstand once it has settled into you. But not yet. Not tonight. Not this early in our journey. For now, let your breath be your anchor. In through the nose, slow and deep, filling the lungs all the way to the bottom. And out through the mouth, long and unhurried, like the tide pulling back from a shore it has known for 10,000 years. You are safe. You are still. The universe is very large, and you are resting in the center of your own small, warm, perfectly sufficient corner of it. Let us talk for a while about time. Because time is the dimension that makes the Fermi Paradox not just interesting but genuinely staggering. If it were simply a question of space, if the issue were merely that the universe is very large and distances are very great, then the silence might feel manageable. Expected, even. Of course we haven't heard from anyone, we might say. Of course the signals haven't reached us yet. Space is enormous, and we are patient, and we simply need to wait a little longer. That would be a comfortable explanation. A reassuring one. The kind that lets you set the question down at the end of the day and sleep easily, knowing that it is simply a matter of time. But time itself is the complication. Because the universe is not young. It is, in the most precise measurements we have been able to make with the finest instruments humanity has ever constructed, approximately 13.8 billion years old. 13.8 billion years. A number so large it functions less like a measurement and more like a kind of poetry. A number that gestures towards something the human mind can acknowledge intellectually but cannot truly feel, the way you can acknowledge the depth of the ocean without ever being able to feel it from the shore. Our own planet is 4.5 billion years old. Life appeared on Earth, in the form of simple single-celled organisms, approximately 3.5 billion years ago. Complex multicellular life took another 2 billion years to develop. And from the first appearance of something recognizably human, creatures who made tools and lit fires and painted the walls of caves with ochre and memory, to this moment, to you lying here in the dark with the whole impossible sky somewhere above you, has been perhaps 300,000 years. Perhaps a little more. In the context of the universe's age, that is nothing. That is so vanishingly, almost laughably brief that if you compressed the entire history of the cosmos into a single calendar year, humanity would appear sometime in the final seconds of December 31st. And here is what that means for the silence. Here is what keeps certain astronomers and physicists awake in the quiet hours of their own nights, staring at ceilings that offer no answers. If life can arise on a planet like ours, a perfectly ordinary planet, orbiting a perfectly ordinary star in a perfectly ordinary region of a perfectly ordinary galaxy, and if the conditions that produced life here are not especially rare or special, which our best current understanding of chemistry and planetary science suggests they are not, then life had the opportunity to arise on other worlds not just once or twice, but over and over again, across billions of years before our own solar system even formed. There are stars in our galaxy that are 12 billion years old. 12 billion. Stars that were ancient when our sun was still a cloud of dust slowly gathering itself together. If planets formed around those stars, if life arose on those planets, if even one of those civilizations survived and grew and developed technology and spread, even slowly, even at a tiny fraction of the speed of light, they would have had billions of years to fill the galaxy entirely. Billions of years. The mathematician and philosopher Michael Hart calculated, in a paper published in 1975 that became one of the foundational documents in the study of this question, that a civilization expanding at just 0.1% of the speed of light, a pace almost leisurely by the standards of what we might one day achieve ourselves, would be able to colonize every star system in the Milky Way within a span of roughly 1 million years. 1 million years sounds long. It is not long. Not against the backdrop of 12 billion years of stellar history. Not against the patience of a universe that has been quietly turning for longer than our minds can truly hold. And so we arrive at the question that has no comfortable answer. The question that sits at the center of all of this like a dark star at the center of a galaxy, unseen but felt, bending everything around it. If the galaxy is old enough to have been colonized many times over, and if life is not so rare that we should expect to be alone, and if even one civilization in the long history of this vast spinning system of stars managed to survive long enough to reach outward, then where is the evidence? Where are the signals? Where are the structures? Where are the ships, the probes, the radio waves, the lights? Where, In all the careful and patient listening we have done, in all the scanning of the sky across every frequency we know how to measure, where is even the faintest whisper of something that should not be there? There is nothing. Not an anomaly that has held up to scrutiny. Not a signal that repeated. Not an artifact in the data that the most rigorous examination has confirmed as something other than noise, or pulsars, or the machinery of purely natural processes doing what natural processes do without any mind behind them. There is just silence. And the silence, when you truly let it settle into you, is not peaceful. It is not the silence of a library or a meadow at dusk. It is something stranger and heavier than that. It is the silence of a house that should have people in it. The silence that you notice not when sound is absent, but when sound that was expected, sound that every reasonable calculation suggested should be there, simply is not. This is what Enrico Fermi understood when he asked his famous question, reportedly over lunch at Los Alamos in the summer of 1950, in a conversation that began casually and then turned, as conversations sometimes do, into something that neither the participants nor anyone else has entirely resolved in the 75 years since. The story is that the conversation wandered from topic to topic, as it does at lunch, and then at some point Fermi asked, quietly and simply, "Where is everybody?" 3 words. Where is everybody? And the people at the table laughed, because it was such a simple way to put it, because the humor of it was immediately apparent. All of this vast and ancient universe, and we sit here, at this table, in this moment, with nothing and no one to show for any of it. But underneath the laughter was something that did not laugh. Something that recognized the weight of the question. Something that understood that the simplicity of those 3 words was not a sign of the question's shallowness, but of its depth. That the most profound questions are sometimes the shortest. In the decades that followed, astronomers and mathematicians and philosophers and biologists and physicists have built entire careers trying to answer what has come to be called the Fermi Paradox. They have proposed dozens of solutions, some hopeful, some technical, some deeply disturbing. They have argued about the definitions of terms and the values of variables and the assumptions baked into the calculations. They have written papers and held conferences and filled libraries with the accumulated weight of their thinking on this single, 3-word question. And still the sky is quiet. One family of answers to Fermi's question suggests that we have been looking at this wrong. That the absence of signal is not absence of civilization, but absence of the kind of civilization we were expecting to find. Perhaps the civilizations that survive long enough to expand across star systems do not broadcast radio waves in all directions like a lighthouse spinning in the dark. Perhaps they have moved beyond that. Perhaps the radio era, the era of technology that leaks electromagnetic radiation carelessly into space, is a phase that a civilization passes through, the way a child passes through a phase of talking loudly before learning the quiet that comes with maturity and understanding. We have been broadcasting in the electromagnetic spectrum for just over a century. A century is nothing. In another century, perhaps, our own broadcasts will have grown quieter as our technology becomes more efficient, more directed, more internalized. And if that is true for us, it may be true for everyone. The civilizations that should be out there may have gone quiet not because they died, but because they grew. It is a comforting thought, in its way. It allows you to imagine the galaxy populated after all, filled with old and quiet minds keeping their lights low not out of fear, but out of something we might call wisdom, or something we have no word for yet. It is the thought that we are not alone in the dark, but simply have not yet learned to see in the way that darkness requires. But there is another thought that lives just beneath that one. A darker thought. A thought that does not comfort so much as it quietly unsettles the foundation of everything you thought you were standing on. It is the thought that perhaps the silence is not a choice. That perhaps the civilizations do not go quiet because they mature into something vast and subtle and beyond our current instruments to detect. Perhaps they go quiet because something happens to them. And that thought has a name. It is called the Great Filter. The idea was first articulated clearly by the economist Robin Hanson in 1998, in a paper whose title asked a question so direct it almost felt impolite. Where are they? Hanson looked at the Fermi Paradox not as a philosophical curiosity, but as a mathematical constraint. If the universe is old, and if the universe is large, and if the conditions for life are not vanishingly rare, then the absence of observable civilizations tells us something. It tells us that somewhere between the formation of a star and the emergence of a spacefaring civilization that survives and expands, something stops the process. Something acts as a wall, a filter, a point through which the vast majority of potential civilizations do not pass. The Great Filter does not have to be a single thing. It could be a series of unlikely steps, each one reducing the probability of success, until the cumulative likelihood of any one planet producing a civilization that reaches the stars becomes so small that the expected number of such civilizations in our observable universe approaches 0. Or 1. Or perhaps just 1. Perhaps exactly us, alone at the edge of an immense silence we built ourselves trying to understand. But the question that Hanson posed, and that has quietly haunted every serious thinker who has encountered it since, is not simply whether the Great Filter exists. It is where it lies. Because that question, seemingly academic, seemingly the kind of thing that belongs in journals and conference rooms and the patient margins of theoretical papers, that question has implications that reach all the way down into the ground beneath your feet and into the specific and irreplaceable fact of your being alive at this moment in this universe. If the Great Filter is behind us, if it lies somewhere in the deep past, in the long chain of events that led from chemistry to biology, from biology to complexity, from complexity to consciousness, then we may have already passed through the hardest part. The filter may have been the formation of the first self-replicating molecule, or the leap from simple prokaryotic cells to the complex eukaryotic cells that carry a nucleus, a leap that took almost 2 billion years on this planet, 2 billion years of life existing and replicating and slowly, blindly struggling before a cell managed to fold a membrane around its own genetic material and become something genuinely new. Or perhaps the filter was the evolution of multicellular life, or of sexual reproduction, or of the particular kind of nervous system that eventually learned to ask questions about itself. Any of these transitions could have been the narrow gate. Any of them could have been the step that almost did not happen, the throw of the cosmic dice that came up in our favor against odds so long that they strain the imagination of anyone who tries to hold them honestly. If one of those steps was the filter, then the galaxy truly may be empty. Not because civilizations rise and fall, but because civilizations almost never rise at all. Because the path from chemistry to consciousness is not merely long and slow but almost impossibly improbable, a road that requires so many unlikely turnings that the vast majority of planets with liquid water and organic molecules and all the right conditions simply stay quiet. Stay simple. Stay small. That would mean we are not typical. It would mean we are not the proof that intelligence is common, but the exception that proves how rare it truly is. It would make every human life not just meaningful in the ordinary sense, but cosmically singular. A flame burning in a darkness so complete that its light may never touch another shore. That is the hopeful reading of the Great Filter. And it is genuinely hopeful, even though it sounds lonely. Because if the filter is behind us, if we already passed through the needle's eye, then the road ahead may be open. Then the future of the civilization, however uncertain it feels from inside it, however fragile it seems when you watch the news or study the history of what we do to each other and to the world that holds us, the future may yet be unimaginably long and wide and full. We may be at the very beginning of something. We may be the civilization that fills the silence, slowly and at great cost and with no guarantee of success, but fills it nonetheless. But there is always a but in this kind of thinking. The but lives in the shadow of the hope, quiet and patient, waiting for the mind to turn toward it. And it is this. If the filter is not behind us, if the silence of the sky is not evidence of how rare our origin was, but of how rare our future will be, then the filter is ahead, waiting, built into the structure of what civilizations become as they grow powerful enough to matter and fragile enough to break in the specific ways that power makes possible. And the search for life beyond our world, which we pursue with such genuine excitement and such careful instruments and such hope, becomes something other than a celebration. It becomes something closer to a warning. Because if we point our telescopes at the sky and we find, someday, not the silence we have grown accustomed to but something else, if we find the chemical signatures of simple life blooming in the atmosphere of a distant world, or the fossilized traces of biology in a rock returned from Mars, or the unmistakable patterns of organic chemistry in the ice plumes of a moon orbiting one of the cold giants at the edge of our own solar system, the feeling that rushes through the scientific community and then through the world will be one of triumph, of vindication, of the long and patient work of generations finally answered. People will weep. They will celebrate. The headlines will say that we are not alone, and for a few days or weeks or months the fact of it will sit at the center of human attention like a sun. And yet, if that discovery is made, if simple life is found somewhere nearby in our own solar neighborhood, if biology turns out to be not a miracle unique to this one pale world but a tendency of chemistry, a thing that happens wherever the conditions allow, then the great filter is almost certainly not behind us. Because if life arises easily, if the first steps from chemistry to biology are not the narrow gate, then the filter must lie somewhere further along the road. In the journey from simple life to complex life, or from complex life to intelligence, or from intelligence to civilization, or from civilization to something that endures. And the closer the filter is to where we stand right now, the more the celebration curdles into something else. Something that does not have a clean name. A kind of retrospective dread. A looking back at the moment of discovery and understanding, slowly and with great reluctance, that what we found was not a door opening but a door closing. That the universe was showing us not that we belong to a community of minds, but that we are approaching the place where minds tend to end. This is why some of the most careful thinkers on this subject, people who have spent their careers in the rigorous and patient discipline of taking the universe seriously, have said, quietly and with genuine feeling behind the words, that the most terrifying discovery we could make would not be the silence continuing forever. The most terrifying discovery would be the finding of life, the confirmation that biology is common, because that confirmation would narrow the list of remaining explanations for the Fermi Paradox down to the ones that live on the darker end of the spectrum. It would point toward what researchers sometimes call late filters. Filters that civilizations approach not in their infancy but in their maturity. Filters that are not about the improbability of arising but about the difficulty of surviving. Filters that may be, in some sense, built into the very nature of what it means to become powerful enough to reach for the stars. And there are many candidates for what a late filter might be. They are not comfortable to consider. But the universe does not arrange itself around our comfort, and the value of looking clearly at difficult things has never been that it makes us feel safe. It has been that it makes us honest. And honesty, even when it costs something, is the only foundation that holds. One candidate is the simplest and in some ways the most familiar, because we have been living inside it for long enough that it has started to feel like background noise rather than the extraordinary and specific danger that it actually is. It is the possibility that civilizations reliably destroy themselves. That the same intelligence which allows a species to develop technology, to harness energy at larger and larger scales, to understand the deep laws of the physical world well enough to manipulate them, that same intelligence carries within it the seeds of its own undoing. That the cognitive tools which make a civilization powerful are not matched, at least not reliably, not automatically, by the wisdom required to use that power without catastrophic consequence. We have our own evidence for how this tension feels from the inside. We have built weapons capable of ending our civilization many times over, and we have come closer to using them than most people who sleep soundly at night fully appreciate. We have altered the chemistry of our atmosphere and the temperature of our oceans at a pace that has no precedent in the geological record outside of mass extinction events. We have built systems of such complexity and interdependence that the failure of any one piece can cascade through the whole in ways that no single mind fully understands or controls. We are, by any reasonable measure, a civilization in the middle of a series of tests that we have not yet passed, and may not pass, and have no guarantee of passing simply by virtue of being clever enough to recognize that they are tests. And if this is true for us, if we, with all our science and all our history and all our accumulated understanding of what happens when power outruns wisdom, if we find these tests genuinely difficult, then perhaps every civilization finds them difficult. Perhaps they are not accidents of our particular history, but features of the landscape. Perhaps the universe has a way of producing minds capable of reshaping their worlds and then leaving those minds to discover, at the moment of their greatest power, that greatness and survival are not the same thing. That the ability to reach is not the same as the wisdom to know what to hold and what to let go. That intelligence, in the long and patient accounting of the cosmos, may be less a solution to the problem of existence than a particularly acute form of it. There is a phrase that appears sometimes in the literature on this subject, used carefully and without drama by researchers who have thought about it longer than most, and the phrase is this: the universe may be a hard place for minds. Not because it is hostile in the way that a predator is hostile, not because there is anything out there that hunts or resents or desires the ending of conscious things, but because the conditions that produce minds also produce, almost inevitably, the capacity for self-destruction at a scale that matches the mind's own reach. The bigger the mind, the bigger the reach. The bigger the reach, the larger the consequences of a single miscalculation. And miscalculations, in the long history of every complex system we have ever studied, are not exceptions. They are the rule. And so we sit with this. We let it settle the way things settle when there is nowhere left to push them. A civilization arises. It is curious and it is hungry and it builds, the way minds build, toward more. More energy. More information. More connectivity. More speed. More understanding of the laws that govern the physical world, which is also more power over the physical world, which is also more ability to change things at a scale that the original environment, the original balance, the original web of dependencies that produced the mind in the first place, was never designed to absorb. And at some point in that arc of growth, a threshold is crossed. Not always the same threshold. Not always the same mistake. But something. A weapon used when it should not have been. A resource exhausted before the alternative was ready. A system made so efficient and so optimized for one outcome that it became catastrophically brittle in the face of something it was never asked to anticipate. And the civilization ends, or diminishes, or fractures into something that no longer has the coherence or the energy or the will to reach outward. And the planet continues. The star continues. The galaxy continues its slow and indifferent rotation. And the silence deepens by exactly one. This is one version of the answer to Fermi's question. It is not the only version. But it is the one that feels most textured, most recognizable, most threaded through with the specific quality of what it actually feels like to be a civilization from the inside. Because from the inside, the dangers do not look like filters. They look like politics. They look like economics. They look like the ordinary friction of beings who disagree about what matters and who should bear the cost of the things that need to change. They look manageable. They look like something that will eventually be sorted out, because it always has been before, because we are still here and still talking and still building, and the fact of our continued existence has a way of feeling like evidence of our continued safety that it is not actually qualified to provide. The astronomer Carl Sagan, who thought about these questions with more public grace and genuine feeling than almost anyone of his generation, wrote about what he called the demographic hypothesis, the idea that civilizations, once they arise, have a characteristic lifetime. A lifespan. Not fixed, not identical from one world to the next, but shaped by the same underlying tensions that shape all complex systems. And he believed, or hoped, or held open with the careful hands of someone who understood that hope and certainty are not the same thing, that the lifetime could be long. That civilizations could learn to navigate the narrow passage between power and wisdom if they tried hard enough and cared enough and were perhaps a little fortunate at the critical moments. He believed that the number of civilizations currently communicating in the galaxy, the variable he and his colleagues called L, for the length of time a civilization remains detectable, was the most important and the most uncertain number in the Drake equation. Everything else in that equation, the rate of star formation, the fraction of stars with planets, the fraction of those planets capable of supporting life, the fraction where life actually arises, the fraction where intelligence emerges. All of those numbers have ranges that astronomers and biologists can at least begin to estimate from evidence and observation and the slow accumulation of data across decades of careful work. But L. The longevity term. The question of how long a civilization survives once it becomes capable of communicating across interstellar distances. That number has no empirical anchor outside of our own example, and our own example is a sample size of 1, which is to say it is barely an example at all. It is a single data point in a distribution we cannot see, a single candle held up in a darkness too vast to illuminate, trying to determine from the quality of its own light whether fire is common or rare in the universe, or whether it burns in every window, in every home, on every world that has ever had the fortune or misfortune of learning how to build one. And so we return, always, to silence. Not the comfortable silence of a room where someone has simply stepped away, where you expect the door to open again at any moment, where the absence feels temporary and warm. But a silence that does not promise return. A silence that has been accumulating for billions of years before we arrive to notice it. A silence so deep and so old that it seems less like an absence of sound and more like a presence in itself. A weight, a texture, something almost atmospheric that presses gently against the edges of thought when you allow yourself to sit with it long enough. Carl Sagan understood this silence. He spent much of his life translating it into words that ordinary people could carry with them, turning the cold arithmetic of cosmology into something felt rather than merely calculated. And when he wrote about the Drake equation, about the longevity term in particular, he did so with a heaviness that is unmistakable in retrospect. Because Sagan believed, as many of the scientists gathered at Green Bank in 1961 had quietly come to believe, that the filter might not lie behind us. That the reason the sky is silent might not be that life is rare, or that intelligence is improbable, or that the transition from simple chemistry to complex biology is so unlikely that we represent a kind of cosmic accident too strange to repeat. He believed the filter might lie ahead, waiting, patient, without malice, because the universe has no malice, only process, only physics, only the long indifferent unfolding of causes and effects across timescales that make the whole of human civilization look like the brief flicker of a match held up against the dark. The physicist Enrico Fermi had asked his question decades earlier, simply, almost casually, over lunch at Los Alamos in 1950. Where is everybody? 3 words, or 4 depending on how you count, and yet somehow those words contained within them one of the most destabilizing questions in the history of human inquiry. Because the math, even rough and provisional as it was, seemed to suggest that if intelligence arose even rarely, even once in every billion stars, the galaxy should by now be full of it. The galaxy is old. It has been forming stars for 10 billion years before our sun ignited. Civilizations with even modest technological ambitions should, if the models are correct, have had time to spread across the entire Milky Way many times over. And yet the radio telescopes continue their slow, patient listening. And yet the sky remains unmarked by the signatures of engineering on the scale we might expect. And yet we are here, apparently alone, or at least apparently uncontacted, which in some ways is more disquieting than true solitude, because it allows for the possibility that something is out there and has simply chosen not to answer. But perhaps the most unsettling hypothesis, the one that surfaces when you follow the logic of the longevity term far enough into the dark, is not that civilizations choose silence, but that they do not survive long enough to practice it. That the very capabilities which allow a species to reach across interstellar distances are the same capabilities that introduce failure modes of a kind that biological evolution has no preparation for. Fire is a tool and fire is a danger, and the same is true at every scale of complexity, from the hand axe to the split atom, from the campfire to the climate, from the signal sent into space to whatever it is we might eventually build that we do not yet have a name for. The longevity term, in this reading, is not merely a sociological question about the lifespan of empires. It is a question about whether intelligence itself is stable. Whether the mind, in its capacity for abstraction and invention and the ruthless optimization of means toward ends, is a configuration that the universe tends to sustain, or one that it tends, with quiet regularity, to dissolve. There is a phrase sometimes used among researchers who study existential risk, a phrase borrowed loosely from the language of evolutionary biology. It is the idea that some traits are locally advantageous but globally catastrophic. That a feature which helps a lineage survive in the short term can, under certain conditions, become the mechanism of its undoing at a longer timescale. Intelligence may be such a trait. It has served us extraordinarily well across the few 100,000 years we have carried it, sharpening our tools, extending our reach, allowing us to model the future and act on those models in ways that no other species on this planet has managed. And yet the same faculty that allowed us to discover the Drake equation, to point telescopes at distant stars and ask whether anyone is listening, has also gifted us with technologies whose consequences extend far beyond the timescales our nervous systems were shaped to navigate. The silence, then, might be a kind of testimony. Not written in any language we can decode, not transmitted on any frequency our instruments have yet tuned to, but legible nonetheless to those willing to sit with the discomfort of the inference. Each star that harbors a quiet world, each solar system that completed its long, slow cooling without ever producing the electromagnetic signature of a civilization, each one of these might be telling us something, not about the rarity of life, but about the rarity of survival. About the narrow and perhaps vanishing corridor between the emergence of power and the wisdom required to carry it without destruction. About whether the universe, in its vast and patient observation of its own contents, has ever witnessed a mind that learned, in time, to hold what it had made. And we do not know. That is the truth that sits at the center of all of this, quiet and immovable. We do not know whether we are the first, or whether we are one of many who reached this particular threshold and stood here, as we are standing now, looking outward into a darkness that returned nothing but its own reflection. We do not know whether the civilizations that came before us, if they existed, if the math allows for them, if the billions of years that preceded our sun's ignition were sufficient time for something to rise and reach and then go quiet. We do not know whether they went quiet by choice or by catastrophe or by some third possibility we have not yet conceived of, because conceiving of it may require a kind of experience we have not yet had and may not survive to have. What we do know is the age of things. And the age of things is, in its own way, a kind of argument. The universe is 13.8 billion years old. Our galaxy is nearly as old. The first generation of stars formed and burned and died and scattered their heavier elements into the interstellar medium long before our sun was even a suggestion in a collapsing cloud of gas. The carbon in your body, the oxygen in the air that moves slowly in and out of you as you rest, the iron that carries warmth through your blood, all of it was forged in stellar cores that completed their entire lives before the Earth existed. You are, in the most literal sense, made of something ancient. Made of the ash of fires that burned when the universe was young, and the night sky would have looked entirely different, and there was no one yet to look at it. This matters because it means that if life follows chemistry, and if intelligence follows complexity, and if the conditions required for both have existed in some regions of the galaxy for billions of years longer than they existed here, then something should have had a tremendous head start. Something should have reached, long before us, whatever it is that we are reaching toward now. And either that something is out there and we cannot detect it, or it is out there and it is not transmitting, or it reached the threshold we are approaching and did not continue past it. Each of these possibilities is strange in its own way. Each carries its own particular weight when you hold it in the dark and let it settle. The astronomer Frank Drake, who drew his equation on a blackboard in a small conference room in West Virginia, lived long enough to see the search he helped inaugurate become a genuine scientific discipline with instruments of extraordinary sensitivity and patience. He lived long enough to see the discovery of exoplanets shift from theoretical possibility to observational reality, to see the Kepler Space Telescope alone confirm the existence of thousands of worlds beyond our sun, to see the fraction of stars with planets move from an unknown variable to something approaching a known quantity. And still the silence held. Still the instruments listened and the sky declined to answer. He said, near the end of his life, that he remained optimistic. That optimism was not naivety but a considered position, a choice made in full awareness of the alternative, because the alternative, that we are truly alone, that in all of this immensity there is only one voice and it belongs to us, carries a weight of its own that is not easy to distribute across a single human mind. There is a kind of vertigo that comes from taking the Fermi Paradox seriously. Not the shallow version of it, the cocktail party version where someone mentions that it is strange we have not found aliens and someone else agrees and then the conversation moves on. But the deep version. The version you arrive at when you sit with the numbers long enough that they stop being numbers and start being something more like a landscape, a terrain you are moving through slowly, in low light, aware that the ground beneath you may not be as solid as it appeared from a distance. That version of the paradox does not resolve neatly. It does not offer a conclusion you can hold comfortably. It opens instead into a series of corridors, each one leading further from certainty, each one lit by a different kind of unease. One corridor leads toward the rare Earth hypothesis, toward the possibility that the conditions that produced us, the stable sun, the large moon moderating our axial tilt, the giant outer planets deflecting asteroid bombardment, the position in the galactic habitable zone, the precise timing of every extinction and recovery across 4 billion years of biological history, are so specific, so improbably concatenated, that they simply do not repeat. That we are the result not of inevitable chemistry but of something closer to the universe's longest sequence of fortunate accidents, a run of improbable outcomes so extended that even in a galaxy of 400 billion stars, the probability of it happening twice converges on something so close to zero that zero becomes a reasonable approximation. That in the arithmetic of existence, we are not a data point in a pattern. We are the pattern's single exception, the one deviation from an otherwise unbroken rule of sterile elegance, of stars burning and dying and scattering their materials across the void without ever producing anything capable of noticing that this is what they are doing. It is a lonely hypothesis. And loneliness at this scale is a different thing than the loneliness we carry in ordinary life. The loneliness of a quiet evening or an unanswered message or the particular ache of feeling unknown inside a room full of people. This loneliness is structural. It is written into the geometry of the situation. If the rare Earth hypothesis is correct, then the universe is not withholding something from us. It is not indifferent in the way that a person can be indifferent, with agency behind the silence. It is indifferent in the way that mathematics is indifferent, in the way that the rules of probability simply do not bend toward outcomes because we desire them, in the way that a vast and ancient darkness does not owe us companionship simply because we are conscious enough to want it. And yet the rare Earth hypothesis is not the only corridor. There is another, and it runs in an entirely different direction, toward a conclusion that is in some ways even more disorienting because it begins not with scarcity but with abundance. This corridor begins with the assumption that life is common, that the chemistry is not so improbable, that given liquid water and organic molecules and sufficient time, something will stir, something will replicate, something will diversify under the pressure of selection until, eventually, across deep stretches of geological time, complexity accumulates the way sediment accumulates, slowly, invisibly, layer by layer, until one day there is something that responds to its environment not merely with chemistry but with behavior, and then not merely with behavior but with thought, and then not merely with thought but with a particular and dangerous capacity to reshape the world according to an internal model of what the world could be. If life is common, then the silence becomes harder to explain by scarcity alone. And so this corridor leads, inevitably, to the filter, to the idea that something interrupts the journey, that between the origin of life and the kind of civilization that leaves permanent marks on the electromagnetic landscape of its solar system, there is at least one transition so difficult, so statistically improbable, so catastrophic in its demands, that most lineages do not make it through. And the question that haunts this corridor, the question that you cannot answer from the inside, is where that filter sits relative to where we are now. If the filter is behind us, we are fortunate beyond easy comprehension. It means that one of the steps we have already taken, perhaps the origin of the first self-replicating molecule, perhaps the transition from prokaryotic to eukaryotic cells, perhaps the emergence of multicellular life, perhaps the development of language and abstract reasoning, was so improbable that it happened here and essentially nowhere else in the observable universe, or nowhere else within any proximity to us that would make detection possible. It means the hard part is over. It means the silence is the silence of an empty room, not the silence of a room where something has already come and gone. But if the filter is ahead of us, the implications unfold in a different direction entirely. And this is where the mind tends to slow, tends to resist the conclusion the logic is reaching toward, because the conclusion is not comfortable and the mind, for very good evolutionary reasons, prefers conclusions that do not undermine the sense that tomorrow is likely to resemble today. If the filter is ahead, it means that civilizations like ours, civilizations that have crossed the thresholds we have already crossed, that have split the atom and built the networks and altered the chemistry of their atmosphere and begun pointing instruments at the stars, typically do not continue. Typically reach some further point along the trajectory and then go quiet. Not gradually, in the slow dissolve of a culture losing interest or redirecting its energy, but terminally, in ways that do not leave a signal. There is no way to look at our civilization from the outside. That is one of the deepest constraints of the situation. We are inside the experiment. We cannot step back far enough to see our own trajectory with the clarity that distance provides. We know where we have been, approximately, with the usual uncertainties of historical interpretation. We know where we are now, in the very rough sense that any single moment in a complex system can be said to be known. But where we are going, and whether the going itself is possible, whether the arc we appear to be on leads somewhere or simply ends, that we cannot see. We have only the sky to consult, and the sky, as we have established, is not answering. What we have instead are models, simulations, the careful formal reasoning of people who have made it their life's work to think rigorously about the conditions under which complex systems remain stable or collapse, about the dynamics of technologies that outpace the institutional structures designed to govern them, about the relationship between capability and wisdom when capability accumulates faster than wisdom can follow. And what those models suggest, with a consistency that is not comforting but is at least honest, is that the window between the acquisition of world-altering power and the development of the judgment required to wield it without self-destruction is narrow. Not impossibly narrow. Not so narrow that the outcome is predetermined, not so narrow that the effort to widen it is futile, but narrow in the way that a mountain pass is narrow, in the way that the margin between a controlled descent and an uncontrolled one is narrow, in the way that certain moments in history look, in retrospect, as though they could have gone differently with a very small change in the initial conditions, a different decision in a particular room on a particular night, a letter read or unread, a warning heeded or dismissed. We have already lived through several such moments and not known it until afterward. The Cuban Missile Crisis, which historians and former participants have revisited with increasing candor in the decades since, appears in retrospect to have been far closer to catastrophe than the public understood at the time, or than the principles themselves fully understood while they were inside it. There was a Soviet submarine, designation B-59, that had lost communication with Moscow and whose officers, believing that war may have already begun above them on the surface, came within a single dissenting vote of launching a nuclear torpedo. One man, one vote in a compartment beneath the ocean, in the dark, under enormous pressure, with no information and every reason to believe the worst. One man chose differently and the thread held. But the thread had been that thin. And the thread being that thin, and our being here to reflect on how thin it was, is not evidence that the thread will always hold. It is evidence only that it held that time. And this is the version of the filter that sits closest to the present moment. Not the deep biological filter of the Cambrian or the Precambrian, not the astronomical filter of the galactic habitable zone or the rare Earth conditions, but the civilizational filter. The one that operates not across billions of years but across centuries and decades. The one that does not require a comet or a supervolcano or a gamma-ray burst from a nearby stellar remnant. The one that requires only the ordinary operation of human nature under conditions that human nature was not designed by evolution to navigate. The ancestral environment that shaped our cognition did not include nuclear arsenals or self-replicating nanotechnology or systems capable of optimizing for objectives at speeds and scales that exceed our ability to monitor or correct them. It included predators and rivals and seasonal scarcity and the dynamics of small social groups. We are, in a very precise sense, ancient minds in a world that has become something our ancient minds did not anticipate and are not naturally equipped to govern. The evolutionary psychologist would say that we are running software designed for the Pleistocene on hardware that has somehow found itself responsible for the Anthropocene. And the mismatch is not trivial. It expresses itself in the way we discount the future, preferring immediate rewards over distant ones even when the math clearly favors patience. It expresses itself in the way we respond to threats that are visible and personal and immediate while remaining relatively unmoved by threats that are statistical and diffuse and measured in decades. It expresses itself in the way our institutions, which are themselves products of historical accident and competing interests rather than deliberate design for long-term stability, tend to optimize for the timescales that matter to the individuals within them rather than the timescales that matter for the civilization as a whole. None of this is a counsel of despair. The recognition of a bias is the beginning of the possibility of correcting for it. The fact that we can name the mismatch, that we can sit here in the quiet of this particular moment and articulate the ways in which our inherited psychology may be failing to meet the demands of our inherited technology, is itself a form of the awareness that the filter, if it exists, requires us to develop. Awareness is not sufficient. But it is necessary, and its necessity is not nothing. It is, in fact, the beginning of everything that could come after, if anything comes after, if the window remains open long enough for something to be built within it. The stars do not care about this. That is worth saying plainly, not as a reproach but as a fact that carries its own strange comfort. The stars are not watching us with hope or anxiety. They are not invested in the outcome. They are doing what they have always done, converting hydrogen to helium in their cores through the slow violence of gravitational pressure, burning across timescales that make the whole drama of biological life on this planet look like a momentary fluctuation in the background noise of a process that would not notice our passing. And yet here we are, inside that fluctuation, aware of it, naming it, turning our instruments toward the sky and asking whether the fluctuation has happened elsewhere, whether the universe has produced this strange recursive loop, matter becoming aware of matter, dust contemplating dust, in any other location within the vast and ancient space that surrounds us on every side without boundary or center. The search continues because the question will not rest. Not because we expect an answer on any particular morning, not because the next signal processed by the next array of dishes pointed at the next candidate star will necessarily resolve anything, but because the asking itself is part of what we are. The curiosity is not incidental to the human condition. It is not a luxury appended to the more serious business of survival. It is, in some deep sense, what survival has been for. The drive to look outward did not arrive late in our story, tacked on after the essentials were secured. It arrived with us, woven into the same neural architecture that learned to recognize the movement of prey across a darkened plain, that mapped the positions of stars to navigate the open sea, that pressed a hand to a cave wall and left a mark that said, simply, I was here. We are the species that asks. We have always been. And now the asking has grown large enough to encompass the cosmos itself, and the cosmos, for the first time in perhaps all of its history, has something inside it that is genuinely curious about the answer. There is a concept in the literature of astrobiology that does not get spoken of enough in ordinary conversation. It is quiet, as most of the truly unsettling ideas are quiet, not loud with catastrophe, but still in the way that only depth can produce. It is called the Great Filter, and to understand it is to understand why the silence of the universe may be the most important thing we have ever heard. The reasoning begins simply. The universe is old. 13.8 billion years old, which is a number that resists genuine comprehension no matter how many times it is stated. The galaxy alone is nearly that old. Stars have been burning since long before our sun was a thought in a collapsing nebula. Planets have been forming around those stars for billions of years, some of them rocky, some of them wet, some of them sitting in the gentle warmth at just the right distance to allow liquid water to pool and persist. And if life, as we believe, arises from chemistry, if it is not a miracle but a process, not an exception but a consequence of the conditions, then it seems, mathematically, almost inevitable that it has happened elsewhere. Many elsewheres. Perhaps an enormous number of elsewheres, scattered across the disk of the Milky Way like seeds cast into an open field. And yet the sky is silent. This is the paradox, as Enrico Fermi is said to have framed it over lunch in 1950, with a casual precision that marks the thinking of physicists who have learned to follow logic wherever it goes without flinching. If life is common, he asked, where is everyone? If civilizations have had billions of years to arise and expand and reach outward, if even a fraction of them have developed the capacity for interstellar communication or travel, then why does the universe look, to our most sensitive instruments, so profoundly, so completely empty of anyone else? The silence demands an explanation. And the explanation that carries the most weight, the one that has proven most durable in the decades since Fermi posed the question, is that somewhere between simple chemistry and a civilization capable of making itself known across stellar distances, something stops. Some step in the sequence fails, or fails often enough that the result is rarity so extreme it approaches uniqueness. This is the filter. A barrier so formidable that virtually everything which begins the journey does not complete it. And the question, The question that ought to produce a very specific kind of vertigo when you sit with it quietly in the dark is whether that barrier lies behind us or ahead. If it lies behind us, then we are the lucky exception. We have already passed through the narrowing. The hard part, abiogenesis, perhaps, the ignition of self-replicating chemistry from inert molecular soup, or the development of the eukaryotic cell with its membrane-bound nucleus and its mitochondria and its capacity for the kind of complexity that eventually becomes a brain, or the emergence of consciousness itself, that most improbable of all developments. Perhaps one or several of these transitions was the filter, and we survived it without knowing. We were the rare ones who made it through. And if that is true, then the silence around us is the silence of a universe in which the universe is mostly asleep, mostly inert, and we are something close to alone, which is both devastating and, in a strange way, magnificent. But if the filter lies ahead of us? This is the sentence that wants to pause here, because what follows, it is not comfortable. If the hard part has not yet happened, if civilizations routinely arise to something like our current level of complexity and capability, and then encounter something they cannot overcome, some internal pressure, some technological threshold, some failure of wisdom at the moment when wisdom is most required, then the silence around us is not evidence of our rarity. It is evidence of a pattern, a recurring outcome. And we are not the rare exception that made it through. We are another iteration of the experiment, somewhere still in the middle of the process, not yet knowing what the late stages look like, carrying within our own civilization the seeds of whatever it is that has silenced every voice that came before us. The Fermi Paradox does not resolve neatly in either direction. The evidence does not yet tell us which side of the filter we inhabit. But the question of which is true may be, without exaggeration, the most consequential question our species has ever faced. Because if we knew the answer, if we could know with certainty, it would change everything about how we understand our moment in time, our obligations to that moment, and what it means that we are still here, still asking, still capable of the kind of reflection that would allow us to recognize the danger even if we cannot yet name its precise shape. That capacity, the ability to look at our own civilization from the outside, to treat ourselves as a data point in a larger pattern, is itself something remarkable and perhaps something rare. Perhaps it is the very thing that makes the question survivable, if surviving it is something that can be chosen rather than simply happening or not happening in the dark. The universe does not issue warnings. This is something we have had to learn, slowly, across the whole of scientific history, and it is a lesson that the mind resists because the mind evolved in a context where warnings existed, where the rustle in the grass meant something, where the change in the quality of light before a storm could be read and responded to. We are creatures built for a world that communicated its dangers in advance, and we carry that expectation with us even when we turn to face something as indifferent as the cosmos. We want the silence to mean something navigable. We want it to be a message we can decode and act upon in time. But the silence does not organize itself around our need to survive it. And yet there is something in the very structure of the question that contains a kind of hope, not the easy hope that arrives before the difficulty is fully understood, but the harder and more durable kind that persists precisely because the difficulty has been seen clearly. To identify the filter is to name it. To name it is to begin the work of examining whether it is truly fixed or whether it is the kind of barrier that yields to understanding, the kind that has looked impassable before and then, slowly, through effort and time and the accumulation of knowledge, revealed itself to have a way through. We do not know yet whether that is true of whatever lies ahead. But the not knowing is not the same as hopelessness. It is the condition that makes effort meaningful. There are researchers who spend their lives thinking about what a successful civilization might look like from the outside, from the vantage point of instruments pointed at a distant star system, asking not whether life is there, but whether intelligence has persisted long enough to leave a mark on its environment that can be seen across light-years of intervening space. The concept they reach for most often is what has come to be called a technosignature, Evidence not of biology but of technology, the kind of large-scale transformation of a planet or a star system that only an advanced civilization would produce. Waste heat is one such signature. Any process that uses energy produces heat, and a civilization that has grown to the scale of managing a significant fraction of its star's output would glow in the infrared in ways that chemistry alone cannot explain. The theoretical physicist Freeman Dyson imagined, in 1960, a structure so vast it would enclose an entire star, a shell or a swarm of solar collectors built by a civilization that had grown beyond the limits of a single planet and needed every photon its sun could offer. We have not found one. We have looked. We continue to look. And the absence of Dyson spheres in our galactic neighborhood is itself a data point, quiet and patient, waiting to be correctly interpreted. What does the absence mean? This is where the thinking becomes genuinely difficult, where the logic branches in ways that all lead somewhere unsettling. One branch says that civilizations do not survive long enough to build such things, that something ends the experiment before it reaches that scale of ambition. Another branch says that they survive but choose differently, that there is some attractor state for mature civilizations that does not involve the expansion and consumption we have always assumed would mark success, that what we think of as the natural direction of growth is actually an early-stage behavior that the universe's oldest and wisest minds have long since moved past. A third branch says that they are there, that the signatures exist, but that our instruments are not yet sensitive enough, our catalogs not yet complete, our understanding of what to look for not yet refined enough to pick the signal out of the noise. Each of these branches is a different universe. Each carries different implications for what we are and where we are going and whether going somewhere is something that will remain available to us. The James Webb Space Telescope, which has been returning images of a depth and clarity that make even experienced astronomers stop and sit quietly for a moment before speaking, has already begun the work of analyzing the atmospheres of exoplanets for chemical signatures that would be difficult to explain without biology. Oxygen, methane, nitrous oxide, gases that react with each other and should not coexist in equilibrium without something continuously replenishing them. The detection of such a combination would not be proof, not immediately, but it would be the first whisper from across the dark, the first suggestion that the chemistry of life has found another foothold somewhere in the immensity of space. We have not heard that whisper yet. The atmospheres examined so far have been ambiguous, or thin, or obscured by clouds that the light cannot fully penetrate. But the examination is still early. The list of candidate worlds is long. And somewhere in that list, some researchers believe there may be a planet whose atmosphere is already telling us something, already broadcasting its chemistry into the infrared in ways that our instruments are only now becoming sensitive enough to hear. The data exists somewhere in the universe, encoded in light that has been traveling for years or decades or centuries toward a telescope that may or may not yet be pointed in the right direction. This is the nature of the search. Not a single dramatic moment of contact, but a slow accumulation of measurements, a gradual narrowing of uncertainty, a process that looks from the inside like patience and from the outside like the universe being interrogated one photon at a time. There is something deeply human about this method. We have always learned the largest things through the accumulation of the smallest evidence. The age of the Earth was not revealed in a single observation but reconstructed from the patient reading of rock layers, from the decay rates of isotopes measured in laboratories over decades, from the slow convergence of geology and physics and chemistry toward a number that no single lifetime could have produced alone. The structure of DNA was not seen but inferred, deduced from the angles of X-ray diffraction patterns and the ratios of base pairs and the geometry of molecules that nobody had ever directly observed. We are a species that builds understanding the way rivers build canyons, not through force but through persistence, through the continuous application of attention to a surface that yields only gradually and only to the kind of pressure that does not give up when the progress is invisible. This is worth holding in the mind when the silence feels defeating. When another candidate's signal resolves into terrestrial interference, when another promising exoplanet turns out to have an atmosphere too thin or too hot or too chemically simple to sustain the complexity we are looking for, when the sky returns again to its default state of beautiful and empty, it is worth remembering that the silence is not the same as an answer. Absence of evidence, as the careful thinkers remind us, is not evidence of absence, particularly when the search is still so young, still so limited in its reach, still confined to a small volume of a galaxy that contains 200 billion stars and has been systematically examined for signs of life for only the last several decades of a civilization that has itself existed for only the last few 100,000 years of a universe that has been running for nearly 14 billion. The search is an infant. The question is ancient. And the relationship between the two will take time to mature into something that deserves to be called a conclusion. Meanwhile, the stars continue their own business, indifferent and extraordinary. In the constellation we call Cygnus, a binary system known as Kepler 452 harbors a planet that has been called Earth's older cousin, a world roughly 60% larger than our own, orbiting a star slightly more massive and luminous than the Sun, in a year that lasts approximately 385 of our days. The system is about 1.5 billion years older than our solar system, which means that if a similar sequence of events unfolded there, if chemistry became biology and biology became complexity and complexity eventually became something that looks up and wonders, then whatever wondering has been happening in that system has had 1.5 billion years more than we have had. 1.5 billion years is a number that cannot be held in the imagination without it collapsing into abstraction, but let it rest there for a moment anyway, felt rather than understood. Whatever we might become in the next million years, in the next 100 million, in the next billion, all of that becoming, compounded, is something that may already have occurred somewhere in the direction of that distant star, quiet behind its veil of 600 light-years. We have not heard from Kepler 452b. We do not know if it has an atmosphere, or water, or anything at all that would interest a biologist. The planet was identified by the transit method, by the faint dimming of starlight as the world passed in front of its sun, and beyond its size and its orbital period we know very little. It is, so far, more symbol than subject, more question than candidate. But that is true of so many of the things that matter most in this search. They begin as possibilities, as shapes in the data that might mean something or might mean nothing, and they wait patiently while the instruments improve and the models sharpen and the human beings doing the looking find better and more precise ways to ask the question they have been asking since the beginning. The search for extraterrestrial intelligence, the formal project that grew from a handful of radio telescopes pointed at nearby stars in the early 1960s, has never detected a confirmed signal of artificial origin. The anomalies have come and gone, the most famous of them annotated in the margins of a printout by a researcher who wrote a single word beside a narrowband signal that appeared once in 1977 and was never heard again. The word was wow. It remains the most evocative piece of punctuation in the history of science, a notation that contains inside it the entire emotional weight of the search, the decades of listening, the hope worn smooth by repetition, breaking open for a single moment into something that felt, just briefly, like confirmation, like the universe finally clearing its throat and saying something back. The signal lasted 72 seconds, which was the duration of the telescope's observation window as the Earth rotated beneath the fixed beam of the Big Ear radio telescope in Ohio. 72 seconds of a narrowband transmission centered near the hydrogen line frequency, the frequency that scientists had long theorized any technologically aware civilization would recognize as a natural meeting point in the electromagnetic spectrum, a cosmic landmark, a frequency that says, if you understand hydrogen, and you are listening, listen here. And something, for 72 seconds, was there. And then it was gone. And in the 49 years since, through all the follow-up observations and improved instruments and dedicated monitoring of that precise patch of sky, it has not returned. What the wow signal was, we do not know. What it was not, we cannot say with certainty. It has been proposed that it was a comet, that hydrogen clouds around an icy body passing through the field of view could produce something resembling what was recorded. The researchers who have examined this explanation are not uniformly convinced. The debate continues in the patient way that scientific debates continue, through papers and responses and the slow accumulation of data that might eventually tilt the balance one way or the other. But for now it remains what it has always been, an anomaly, a moment in the data that does not resolve into comfortable explanation, that sits at the edge of what we know and refuses to move further in either direction. This is the texture of the search. Not revelation but ambiguity. Not answers but the kind of questions that deepen rather than diminish with time. There is a particular quality to the uncertainty that surrounds the search for extraterrestrial intelligence that distinguishes it from most other scientific uncertainties, and that quality is its totality. In most areas of inquiry, we have at least some data to constrain the possibilities. We know something about the thing we are studying, even if we do not yet know everything. But in the search for other minds in the universe, we have, so far, precisely one example of what we are looking for. One instance of biology producing technology, producing the capacity for communication across interstellar distances. One civilization, young and uncertain and still learning the rules of the cosmos it inhabits. And from a sample size of one, it is extraordinarily difficult to draw conclusions about frequency. We do not know if we are typical or exceptional. We do not know if intelligence is the kind of thing the universe produces readily or reluctantly. We have no second data point against which to measure ourselves, and the absence of that second point is not just a gap in our knowledge. It is the gap, the central, defining silence around which everything else in this conversation is arranged. And yet the conversation continues, because stopping is not something the human mind does easily when the question is this large and this close to the center of what we are. The SETI Institute, headquartered in California and supported by a combination of private donations and research partnerships, continues to operate instruments and analyze data and expand the scope of the search in ways that would have seemed like science fiction to the researchers who first pointed a radio telescope at Tau Ceti in 1960 and sat down to listen. The Allen Telescope Array, a field of radio dishes in the high desert of Northern California, can monitor multiple star systems simultaneously, listening across a broad range of frequencies for the kind of signal that does not occur naturally, the kind of narrow, structured, repeating transmission that says, "This was made." The Breakthrough Listen initiative, funded by a philanthropic commitment of $100 million announced in 2015, has brought a new scale of resources to the search, using major observatories to survey the nearest million stars and the nearest 100 galaxies for signals that would not arise from any known physical process. These are serious efforts, conducted by serious scientists, using the most sensitive instruments our civilization has yet produced. And they have found, so far, the same thing that every previous search has found. Silence. Beautiful, heavy, humbling silence. The kind of silence that is not empty but full of everything we do not yet know, full of the specific quality of a question that has not been answered, which is different from a question that has been answered no. The distinction matters. It matters enormously, because a question that has not been answered is still alive, still open, still capable of resolving in either direction on some morning that has not yet arrived, when some instrument is pointed at some star in some configuration that has not yet been tried, and something in the data is different from everything that came before it, and a researcher leans closer to a screen in a quiet room and feels the specific sensation of standing at the edge of what humanity has ever known. That moment may come. It may not come in our lifetimes. It may come tomorrow, which is a sentence that has been true every day for 60 years of searching and has not yet been followed by the thing it anticipates. But it remains true. It remains true in the way that all genuine possibilities remain true until they are foreclosed, and this one has not been foreclosed. The universe has not told us no. It has told us nothing, which leaves the door open, in a way that no amount of silence can entirely close. And there is something in that openness, that sustained and unresolved possibility, that functions less like frustration and more like an invitation. An invitation to continue, to refine the instruments and widen the survey, and ask the question with greater precision and greater humility and greater awareness of how much we do not yet know about what we are even looking for. Because that, too, is part of what the silence has taught us. That we may have been listening for the wrong things. That a civilization 1 billion years older than ours may not communicate by radio any more than we communicate by smoke signal. That the signatures of intelligence at scales we cannot yet imagine may be written in phenomena we are only beginning to understand, in patterns of gravitational waves, or in the large-scale structure of matter arranged in ways that seem too ordered to be accidental, or in wavelengths and modalities that our physics has not yet named. This is not a retreat from the search. It is a deepening of it. The recognition that our current methods are early and our assumptions are shaped by the only example we have ever known, which is ourselves, is not a reason to stop, but a reason to hold the search more lightly, to carry it with the kind of open-handed attention that does not insist on finding what it expected, but remains genuinely ready to be surprised by what arrives instead. The universe has surprised us before. It has surprised us repeatedly and profoundly, at every scale from the subatomic to the cosmological, in ways that no prior framework could have predicted. There is no particular reason to believe that the question of life and intelligence will be the exception to that pattern. The answer, when it comes, may not look like anything we have prepared for, and that, in its own way, is among the most extraordinary things about the search. It may end not with recognition, but with a particular vertigo of encountering something so genuinely other that the mind must expand simply to hold it. We are, in the end, a young species on a middle-aged planet orbiting an ordinary star in the outer regions of a galaxy that contains more stars than there are grains of sand on all the beaches of the Earth, inside a universe that contains more galaxies than that. This fact is not meant to diminish us. It is meant to locate us, to give us our actual coordinates in the vastness, which are not the coordinates of the center or the apex or the inevitable culmination of everything that came before. We are somewhere. We are somewhen. We are a particular and improbable arrangement of matter that has, through a sequence of events stretching back nearly 4 billion years on this planet alone, arrived at the capacity to contemplate its own improbability. That is not nothing. That is, by any measure we have available to us, extraordinary. The carbon in our bodies was forged in the cores of stars that died before our sun was born. The iron in our blood was scattered across space by supernovae, by the violent and spectacular deaths of massive suns that burned bright and brief and ended in explosions that briefly outshone entire galaxies. We are made of the universe looking at itself. We are what happens when the process becomes recursive, when matter develops the capacity to wonder about matter, when the cosmos folds back on itself and asks what it is. And it is in this context that the silence becomes not a source of despair, but of something closer to sacred weight. If we are alone, then we are the universe's only mirror. We are the one place in all of this immensity where the light has organized itself into something capable of asking where else the light has done this. That is a responsibility so large it barely fits inside language. And if we are not alone, if somewhere in the dark there are other mirrors, other recursions, other arrangements of matter that have arrived at awareness through their own long and improbable sequence of accidents and selections and survivals, then the silence between us is not emptiness. It is distance. And distance, unlike absence, can be crossed. Distance is a problem with a solution, even if the solution requires timescales that dwarf everything we think of as history. The search continues tonight. The dishes are pointed at the sky. The data is flowing through the processors in long rivers of numbers that human eyes will examine tomorrow, or next week, or next year, looking for the pattern that does not belong, the signal that rises above the noise with a structure that could only have been placed there by intention. Somewhere above the atmosphere, above the thin blue line of air that separates the living surface of this planet from the rest of everything, the light from 100 billion galaxies is falling toward us, carrying inside it whatever information the universe has chosen to encode. We are learning, slowly, to read it. The stars do not answer. But they do not look away. They burn on, patient and ancient and indifferent and beautiful, and we keep watching them, which is perhaps the most human thing we do. We watch. We listen. We wait with instruments we built from the same atoms the stars discarded. We ask the question that may never be fully answered, and we ask it again the next night and the night after that, because the asking is not separate from the living. It is the living. It is what the long journey from the first cell to this moment has been quietly, improbably, magnificently building toward. And the universe holds its silence. And we hold our question. And between the two, something that might be called meaning continues to breathe.